Okay, so we're gonna do some geometry, unit 3, review. So solve for each of the following. So they want us to solve for this one. All right, so if we know that this is the altitude, that means that that's a right angle, good. That means these are equal, good. They're telling us that ST is 40, so that's right here. TQ, that's Q, I'm assuming, right, is
Yeah.
2x plus 3y. So one of our equations is going to be 40 equals 2x plus 3y, right?
Mm-hmm.
And then they also say that RST is, that's y, and the other one is 2x. So can we show that those are equal to each other? We can. Those two triangles are equal because if you think about side or the reflexive property, then you have side angle side, right?
Mm-hmm.
Side angle side. So that means that these two things are equal to each other, right?
Yep.
So our other equation is that y equals 2x,
Okay.
right? So you can do either substitution or elimination to solve this system of equations. Do you remember doing this in algebra?
Yeah.
Okay, so which method would you like to use, substitution or elimination?
Probably substitution.
Yeah, good idea. So you're going to substitute this in for y. So rewrite the equation as 40 equals 2x plus 3 times 2x, which means 2x plus 6x, which is 8x equals 40, which means x equals 5, right?
Mm-hmm.
And if x equals 5, excuse me, then y equals 10. Just plug it into either equation, whichever one's easier. Okay.
Okay.
And then it says find RSW, and where's RSW? That's y. Oh no, I'm sorry, that's this one. RSW is going to be the complement of y, right?
Supplement, right? Because it's
Sorry,
in the
supplement,
okay. So
right?
it's
And
180
what would
minus.
this, what's that?
So then it's just like 180 minus 10, right?
You got it. Now that doesn't look like what the answers would be, right? This
Mm-hmm.
is not drawn to scale, but it is correct.
Okay.
Good. Any questions about that?
No.
All right. Given those, prove that ABC is isosceles. ABC. Okay, so we're going to use, um, do they want you to do a column proof, a 2-column proof?
Uh, yeah, like statements and reasons. Yeah.
Okay, so the first thing you're going to do is you're going to use addition, right?
Mm-hmm.
To say that that angle is equal to this angle. So call it
Okay.
D DBA is equal to uh, ECA,
Okay.
right?
Mm-hmm.
And so that's the addition property, and then you can show that 3 and 4 are equal by um, this is where it gets a little bit tricky to which one do we use. Do we want to use uh, subtraction property or supplement?
Probably.
Supplement maybe. What I don't have your book with you, but
Let me
or
check.
I don't have the in the back of your book. You just kind of take a look at that. You could probably do either one. You could probably state that 3 and 4 are, yeah, you could probably say 3 and 4 are congruent because um, supplements of congruent angles are congruent. I think that's the
Yeah,
property.
that's what it says.
Yeah. Okay. And then you say ABC is isosceles by definition of isosceles.
Okay.
That makes sense? Do you think you can write that out okay?
Yeah.
Okay. We can come back if we have time at the end and write it out if you want, but if you understood that, then we'll just move on, okay?
Okay.
So this next one says JH equals KH. So JH equals, oops, JH equals KH, okay? GHG equals, well, that's kind of hard to tell. Let's color it. That angle or that side, that line equals HM equals that line. Okay, so that equals that. All right, and 5 equals 6. So that equals that. They want us to conclude that the triangles are equal to each other. And the triangles are the bigger triangles. Okay, so what we're going to do for this one, we can see that that angle right there in the middle, I can add that angle to 6, and I can add it to 5, and that will give me that that big angle equals that big angle.
Okay.
That would be by the addition, I believe, the addition property. Do you see that?
Yeah.
So that would give you that this big angle here is equal to this big angle here because you're adding the same thing. You're adding that yellow angle to congruent angles.
Yeah. Okay, that makes sense.
Okay, and then you would have side, angle, side, side, angle, side.
Oh.
See it?
Yeah.
And again, you can write that up yourself if you want. Go back and listen to this video if you're having a hard time with it and write it up.
Yeah.
Okay? Sound good?
Mm-hmm.
Okay. Next one. It says given 3 and 4 are congruent. Okay, so 3 and 4 are congruent. We'll just do that. Bx and ay are equal. Bx and ay are equal. Bw and az. Bw and az. Okay, so now do you see that you need this angle right here? Do you see that the angle you need is this one and this one? You want to show that those are equal. And how can I show that? What property would I use to show that?
Could you do supplementary?
I think it's that property that we just referred to. The supplements of congruent angles are congruent.
Yeah, that's what yeah.
I don't know what your teacher wants you to write, but I think probably just write that out.
Yeah, I'm gonna assume that's right. I don't have the answers for this one, but
supplements of congruent angles are congruent, and that would give you that one, and then you can show that these two triangles are equal to each other, right?
mm-hmm.
And then you can say that these angles are equal to each other. These blue angles I'm drawing in are equal to each other by CPCTC, right? And then you can say that WTZ is isosceles by definition of isosceles.
Okay.
Good. Okay, find the restrictions on the value of x. Okay, yeah, these are kind of tricky here. Given that the measure of angle A is greater than the measure of angle C. So they're telling you that A is bigger than C. That would mean that the side across from it has to be bigger than the side across from the other one. You understand how I came up with that?
Yeah, because like if you're like substituting Yeah, I get it. Yeah.
The
Okay.
side, yeah, there's a theorem or property that says um, the biggest side is across from the biggest angle, basically. The biggest side is going to be across from the biggest angle. So if A is bigger than C, then this has to be bigger than this.
Okay.
Okay.
Mhm.
Um, let's see, what would the other restriction be? I think the other restriction would be whichever one. Let's see. I think what I would maybe tend to do is write that they have to be positive. So 4x plus 48 has to be greater than 0, and 8 minus x has to be greater than 0. And then just solve both of those. And you don't need to use both of those probably, but you'll kind of figure out which one is the one you'd want to use. So 4x has to be greater than negative 48. So x has to be greater than negative 12.
Okay.
Or for this one, if I added x to both sides, x has to be less than 8. So let's see if these make sense. Well, let's solve this one now and see what that tells us. So I'm going to move the x over to the right. So that means 5x, and I'm going to subtract 48, negative 40. So x has to be less than negative 8. So here's what I have. I know that I'm going to write them all so the x is on the left. I know that x has to be less than negative 8. I know that y has to be greater than negative 12, and x has to be less than positive 8.
Okay.
So which one do I not have to write of these?
The 8?
Let's think about the number line here, what we have. Here's 8, here's negative 8, here's negative 12, and here's positive 8. I'll color code these. This one is saying that x is less than that. So it's saying this. Got it?
Mhm.
This one is saying x is less than positive 8. So it's saying this. And this one is saying that x is greater than negative 12. So it's saying that. So which of those circles, which of those lines do I really not need?
X is less than 8. Or it's either going to be X is less
I know
than
I'm trying to think. I'm actually trying to think of this myself. I'm not sure. I'm asking you, but I'm actually trying to think in my head, which one do I really not need?
Okay. The problem says negative 8
Yeah,
and X negative
yeah.
12
So
is
this is in this one you don't use because that if all of these have to be true, then you don't use this one because that would mean that this isn't necessarily true. So your answer is right here. Is that what the answer said?
yeah.
Is this the answer?
How would I know though whether to use negative 12 or 8 in this case?
Well, that's what I was doing. That's why I did these. What we're trying to do is we know that these two things we know that this inequality has to be true, right? But we also know that these both have to be positive side lengths. So these values have to be positive. So that's why I set up each one of them. And that's why I'm setting up the number line so I can visualize it a little bit better. If all three of these things have to be true, so really the reason that we're doing this is because this is an and. All three of these things have to be true.
Okay.
But look at this one right here. If this is true, is it also the case that this is true necessarily? Like if my point is here at 0, does 0 work for all three of these things? 0 would work for the yellow one and the red one, but it wouldn't work for the blue one, right? -6 would work for the yellow one and the red one, but not for the blue one. But all three of these have to be true.
Okay.
You understand? So that's why this one is eliminated. That's how I think. That's the way that my mind works, at least. I'm not sure if there's another way that your teacher is teaching it to you. So the answer would be just this right here, because this is not included in this one. But I had to write them all out so that I can see which ones were like the stronger statements.
Okay. Can like to check to make sure that it's like I have the right two, am I able to substitute them back into the equations? And then would it help me figure out like whether to use like the
Yes, it kind of would, because if you plug in, like I said, if you plug in 0, see if it works. Plug in 0 up here, you get 8. And if you plug in 0 here, you get 48. But this had to be bigger than this.
Oh, okay.
So that didn't work. If you plug in -9, plugging in -9, it gets you 15, which is a positive value. Plugging in -9 here would give you a number less than that. What would it give you?
Negative something.
Well, yeah, plus 48 though.
Hold on. It would be 12.
12, which is less than 15. So that worked.
Okay.
So yeah, plugging in values will help you know if you did it right. Because what you're going to get is when you get to the right of -8, you're going to be like, oh no, that doesn't work, because now this one is bigger than this one. And if you get to the left of -12, you're going to be like, no, that doesn't work because one of them is not positive, because this one wouldn't be positive anymore.
Okay.
Like if you put -13 in here, -13 times 4 is bigger than 48. So it's going to be a negative number, but you can't have a negative number on a side length.
Yeah.
That makes sense? I don't know how your teacher may have taught that to you.
Yeah.
Do you have notes?
Just kind of gave us the problem, but yeah.
Does that make sense how I'm coming up with it?
Yeah.
Again, I don't know if there's a better way for me to explain it to you. I don't know, but the way I think of it, just my math mind, I immediately go to, well, I know that this has to be true because of what I said about the angles and sides across from them. And then I thought, well, the other restriction would be that they have to be positive. Each of these has to be positive.
Okay.
Right? And when you look at it like that, realize that, well, both of these things have to be true. If both of these things have to be true, then only this one is the one that I write. Like I said with my example, because all of these numbers in here, they make the yellow one true and the red one true, but they don't make the blue one true. But all three of these things have to be true.
Okay.
Does that make sense? So I get rid of it and I just use these two.
Okay.
Okay. Do you have some more questions? We got about 9 minutes left. You have some more you can find, or you want to try to find another one of those? I know there were some other good. I was helping another honors geo kid yesterday, and he had some good questions about, like, or maybe Saturday, had some good questions about like the restrictions on X with some other ones. Do you have any more like that?
I don't have any more with the restrictions of X. I do have more proofs though.
Okay, yeah, put a couple more on there.
Yeah, hold on. I just have to get it. It might take a second.
No worries. All right, so let's come up with this. Again, let's just think it out. Do you like how I'm going about it, where I'm kind of talking it out and leaving it to you to write it up? Okay, given that it's a circle, so the first thing I'm going to do is draw in my radii. There's one and there's one, and I'm going to state that those are equal to each other. I'm pretty sure I'll need that.
Okay.
Okay, and then KR is an altitude and median of K of the triangle KNC. So if it's a median, that means that these two are equal, right? And if it's an altitude, that means that it's a right angle. All of these are right angles, in fact.
Yeah.
Got it? So did you learn hypotenuse leg yet?
That's the HL theorem, right?
Yeah, have you learned that?
Yeah, I think that's the topic that this one's from.
Oh, perfect. So there's HL. HL will show you that these two are congruent. These two triangles are congruent.
Okay.
Oh, actually, we don't even need that. I'm so sorry. We don't even need these right here, as it turns out, because we have this one right there with what is it called? Reflexive property, right?
Yeah.
So since this is equal to itself, we actually have a side angle side. And side angle side will establish that these two triangles are equal, and then NK and CK by CPCTC.
Okay.
Got it?
Yeah.
Got another one? Page 7?
Yeah. Let me just put it in.
Okay, given K, P, R, and SAW. KPR is congruent to SAW. So this is equal to this. This is equal to this. And this whole thing is equal to this whole thing. Okay, and the angles also are equal. RM bisects KRP. RM bisects K, the angle KRP. Okay, so that means these angles are equal to each other, right?
Mm-hmm.
And these angles, I'm assuming, are equal to each other. Yeah. They want us to prove that RM is congruent to WT. RM, WT. Okay. Let's see, what's our strategy on this one? So RM and WT are congruent. So if we could somehow come up with one, if we could like prove that these two triangles are congruent, then CPCTC would give us what we need, right?
Yeah.
So let's see how we can do that. We have, all right. So we know that these two triangles are congruent to each other, right? And so there's a property that says maybe the division property. Do you have a division property?
Yeah.
I think the division we can use the division property to show that these angles are both equal to each other.
I said that it says if angles are congruent, then their divisions are congruent. So it
Right.
probably
Yeah. So these angles, since these big angles were congruent, if we bisect each of them, then those angles are going to be congruent. That's what that says.
okay.
Okay. So we use that. And then we also say, because the original big ones were congruent, that these angles are congruent right here. The blue ones are congruent.
Okay.
And so now what can I do to show that the smaller one is congruent? What can I use to show that?
ASA.
Yep. Angle, side angle.
But
Angle, side.
then?
Sorry, I couldn't hear you. Say it again.
How are A and P congruent then?
A and P?
Yeah, like SAW
Because
and
they told us at the very beginning that the two triangles are congruent.
oh, okay.
And since the two triangles are congruent, those blue ones are congruent by CP/CTC.
Okay.
Got it? So the trickiest property for that one was the division property.
Uh-huh.
That was the hardest part of it.
Yeah.
Okay, got it? And then the final step is CP/CTC.
Okay.
Sound good?
Yeah.
All right. Good job and good luck tomorrow on your quiz.
Thank you.
I'll see you next time.